Hey class, welcome to another internet session here. Today we're going to talk about just what the title says, Production Possibilities Frontier / Curve. We're not going to do anything past part one in a video session. We might do a little bit in class, but for right now, this is kind of all that we need to know. So let's get started. This one might go a little quicker because it's kind of involved, so I'm going to try and do the best that I can here to try and save time. So one of the first things we need to talk about is in economics we use what we call models, and basically these models are just kind of graphs, very linear, very simple, just an x-axis and a y-axis. So in economics it's just a simplified representation of a complex theory. Okay, we like to break things down to the simplest, most efficient way that we can use it, and it helps us understand and predict what's going to happen. And then what we're going to talk about today is kind of the first type of model that we usually talk about in economics, and that's called a production possibilities model, and it's frequently represented as a graph. Now I'm going to say PPF, usually production possibilities frontier. So what does that mean? This is a PPF, a production possibilities frontier, and it's also called a model. And what we can see here in a society, it's that we make two things. We make corn and soybeans, and that on this line here, this production possibilities that's bowed out from the center, it shows us a few things. It represents the potential output of an economic entity, okay, how much they can produce at any given time, using all types of resources, land, labor, capital, yada, yada, yada. It can be an individual, or it can be an entire economy. This could be, the U.S. and what they do with corn and soybeans, right? It can be a firm, it can be a whole country. But it's also called a frontier, right? Because on a frontier, you can't go past it. It's kind of the last thing, right? And we'll talk about that in just a moment. But this line right here, this dark line right here, is called the PPF, the Production Possibilities Frontier. Now you're going to see frontier interchanged with curve. I'm going to try and keep it F, frontier, for as long as we can. So again, represents the potential output of the entity represented. So this is a farm. Let's say this PPF is a farm run by Carol Inadell, whoever that might be, okay? And this is her PPF. So we've simplified the economic realities by assuming that farmer Inadell can only produce two products, right? On her farm, she only produces corn and soybean. And also, if she's efficient, she will produce some combination of those two products represented on the graph. Now, what does that mean? This graph measures the utilization of all three different resources, okay? Farmer Inadell is the entrepreneur, but this graph represents the utilization of land, labor, and capital that's available to her. So let's get into it. Now, most importantly, I'm going to go back here just a second. This model includes the concept of opportunity cost. Okay, when we do something, we have to give up something. And this is a great representation of how we can look at opportunity cost in kind of a numerical way. So let's say that she can produce 10,000 bushels of corn, but she can't produce any soybeans, right? 10,000, 0 soybeans. On the other hand, if she decides to produce some soybeans, she'll have to give up some of the corn, right? That opportunity cost aspect there. The more soybeans she produces, the less corn she can, and vice versa. So, the frontier is bowed out because as Farmer Inadell increases her production of corn, she will forego a greater amount of soybeans. And as she increases her production of corn, she'll lose some soybeans. So let's look at an example. If Inadell produced 2,000 bushels of corn, she would be able to produce about 9,800 bushels of soybeans. Okay, she produces 200 bushels of corn. She can't produce all the soybeans. She can't produce all 10,000. So we fly the bird over, hits the wall, 9,800. Okay, just about right there. Okay, do you see that? If Inadell to produce an additional 1,000 bushels of corn, so she's going from 2,000 to 3,000, she'll again lose another 400 bushels of soybeans. Okay. We go up here, bird flies over, hits the wall, flies dead, okay? So we give up soybeans by making corn. So the opportunity cost of the additional 1,000 bushels of corn is the loss of 400 bushels of soybeans. So as the farmer increases the production of corn and moves from an output of 8,000 bushels to 9,000 bushels, the output of soybeans drops from 5,000 to 3,000. Okay, so let's say she's been making 8, she wants to produce more corn, okay? Well, while she was making 8, she could only make 5,000 bushels of soybeans, right? But as she increases 1,000 more bushels of corn, she loses 2,000 bushels of soybeans, okay? So then the opportunity cost of the additional 1,000 bushels of corn is 2,000 bushels of soybeans. Do you see that relationship there? As she gains more corn, she loses more soybeans. So the bowed out PPC, or PPF, illustrates the concept of increasing cost. As she keeps increasing the amount of corn she produces, she keeps increasing the amount she loses in soybeans. And it would go vice versa. And that's why it's bowed out there. So each additional unit of corn produced requires an increasing amount of foregoing soybean production. So each amount of corn, each unit of corn that she keeps on producing, we lose ever increasing amounts of soybeans. Right? We lose those. Now the same would be true if an increase in the production of soybeans. As more soybeans are produced, the opportunity cost on foregoing corn increases. The more soybeans she makes, the less corn she can. All right? So why does this occur? Well, let's take a look at some of this. Some of the resources available to farmer Inadel are more productive in corn, and other resources are more productive in soybeans. So as the farmer increases the production of corn, she will convert the land that is less suitable for soybeans to the production of corn. It's just utilization of resources, being efficient. So as she continues to increase her production of corn, she will start to use land that is more productive in the growing of soybeans. You see that? She will start to use land that is more productive in the growing of soybeans. So, a couple notes here. What if she produces 6,000 bushels of corn and 5,000 bushels of soybeans? Where does that land us? 6,000 bushels of corn, about 5,000 bushels. Oh, we're inside the line there. Okay? We're at that point, and that's not good. Okay? We call that inside the line. So this would be considered, her resources would be underutilized. We're still making corn, we're still making soybeans, but we want to be on this line. Okay, this is what's attainable, and this is the most efficient use of resources. We're being under efficient here. Okay, but what if we produce 9,000 of both? 9,000 soybeans come up to 9,000. Now we're outside the line. Let me show the dot here in a second. Okay, that's okay, but we can't do it. All right, that's outside the line. Now what does this mean? We're unable. When would we be able to? If we change our technology. And if we change technology, that would allow more productivity with the same amount of land, labor, and capital. Okay? This is like a goal. This is where we want to be. We want to keep pushing this bowed out line here, this bowed out line to the dot. All right? That's the most important thing. We want to keep increasing. Okay? So we need to change the amount of land available, change the amount of capital, right? We need to grow more, make more, sell more. And then we need to change the amount of labor. So we need more labor, we need more land, and we need more capital. So we're going to stop there. We're not going to talk about constant cost because it's a little bit more AP, and we're not going to work with it. It's not going to concern us all that much. Okay? So hopefully you guys learned some things. Remember, use these concepts, learn these concepts, and we'll talk about these concepts. All right? Have a good one.